Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right. Well, welcome to Happy Path Programming. So before we dive into our guest today, we had the Winter Tech Forum up here in Crested Butte, Colorado last week, and had a handful of nerds come up for that and had a great time.
We were losing people just right up until the end, but the reassuring thing was that it was still great, even though we experimented with having only a single session because there was only 10 of us really.
Yeah.
And so it was hard to
single track.
It was hard. And one of the sessions that I didn't suggest, someone else said, was about marketing the conference, because they're going, yeah, we want to get more people here. We don't want the conference to peter out, etc. And so they talked about different things that we could do, because it really is nice when you have multiple tracks and you can
make
choose
some choices about what you want to go to.
Yes. So we definitely learned some things. The yurt dinner was really a good experience, and it's
we had some fun projects that we worked on.
We did.
We got some Pickle, the new Apple configuration language, working for GitHub Actions,
which I gotta say I was skeptical about.
Delightful,
partly because
you've heard the promises before.
Well, in Apple, I don't know. I've seen really bad Apple software, so I was suspicious of that. But and also configuration. I mean, how many configuration systems have we seen? And they all had pretty significant flaws. And it's wow. I mean, Pickle is like, okay, that's where we're going, man.
Yeah,
because it's a real language.
It's a delightful experience.
Oh my gosh! And we were able to just guess at things, and most of the time we were right.
Guest-driven development worked with Pickle. That was. So we're hoping to have a Pickle person on sometime to talk more about that.
To dive into it, because that, I got to say, I was impressed. Yeah, beginning to end with that experience.
So we recorded a few of the sessions from the conference, and we'll try to get those posted soon.
Mm-hmm. Yeah.
Okay, well, with that, welcome, Gwen Shapira. Did I get your last name right?
You got my last name right.
Awesome.
Happy to be on the show.
Yeah, great to have you, Gwen. So let me give a little bit of my background of knowing you, and I don't know if we've ever even met in person, but my first kind of encounter with you was you are one of the co-creators of Kafka when you were at LinkedIn. Am I getting that part right? And we can
actually no. A lot of people think that, and that is incorrect. I was not a co-creator of Kafka, and I was not in LinkedIn. I was an early adopter while I was actually doing professional services at Cloudera.
Okay.
And I started, when Cloudera was the Hadoop company back in the day. And big problem with Hadoop was how do we get data into it? And I was trying to help my customers and experimenting with different methods. And my husband was at LinkedIn at the time. And he said, our team is using something called Kafka. And I started using it, and it's pretty cool. Maybe you should try using it too. We now open source it to Apache, so you and your customers can try it. And we tried it. And it was amazing. But like any new software that you start using, maybe a year after it came out, it had bugs and it had missing features. So it was very natural for me. During the day, my customer tells me I was trying to do this and it didn't quite work the way I expected. I was like, let me look if I can do anything about it. So I looked, and if I could figure out how to do it, I contributed a patch. And the thing that really got me about Kafka is that the community was so great. So welcoming. I still remember, I was in Portland consulting to a very big, well-known company. In the evening, I wanted to fix a bug for them. I was sitting in this, they have these pubs in the converted schools up in Oregon. And so I was sitting in one of those drinking my beer.
I've been to that pub. It's, what's the name of that?
McKimmon? Something like that.
Oh, it's such a fun place going into this old school, and it's like many rooms that are different pubs and things. It's super fun.
Sounds like Portland.
Yeah.
Exactly. So I was sitting in one of those, and I wrote my patch and I submitted it. And then like an hour later, I get a response from Jay Krebs. This looks okay, but have you thought about this bit? And I was like, yeah, I did think about this bit. This is why I'm doing it this way. And like the next day, I could tell my customer, hey, can you build the latest Kafka because the issue is fixed for you?
Wow.
And they were very impressed. I felt really good. And this obviously starts a really good cycle of contributing to a project. So that's kind of how I got pulled in.
It's funny that I imagined that you were one of the creators of it because, and I guess you are a significant contributor to Kafka, but I'd somehow imagined that history. So because you've been so, I think, instrumental in making Kafka the amazing thing that it is. So so that's funny. But so then in your journey, let me go back. One of the and maybe this is leaping forward a little bit too much, but one of the distinct things that I remember about you was you gave a keynote at I think it was the Kafka conference. What's the name of the Kafka Confluent conference or something like that? So you gave this keynote, and it was the best developer oriented keynote I'd ever seen because you were very technical. You were able to connect with the developers, create some enthusiasm around Kafka, and so yeah, that always stood out to me as being this like amazing Gwen moment of most of these keynotes are so dry and marketing driven, and yours was just this authentic developer oriented thing. And so I love that keynote, and you've probably done many of those keynotes, but there was one in particular that I'd watched that I love. So so then tell us about your journey to Confluent, and ultimately we'll get to where you are today. But how did that work? You were contributing to Kafka, and then
So obviously
Confluent
I
was
made
like,
friends.
what is that?
And so obviously while contributing to a project, you make friends and you go to meetups or you meet them. I think Strata was the big conference back then. So you kind of meet people, you talk to them. And then I think about a year after Confluent was founded, I think I was thinking about joining for a while. I was just so passionate about Kafka, and Cloudera had many interests. And the thing that happened was that Cloudera tried to promote me. And I did not want to get promoted. Even though, and my manager was amazing, and like I had really the best mentors one can possibly dream of, and like such a strong engineers. But I didn't want to lead a team. I wanted to work on Kafka.
Yeah.
And it was a bit of a conflict there because for Cloudera, Kafka was not that important. It was not the core business. So for them, it's like, we have this person who is good prominent engineer. Why are they working on the things that is not that critical for our business?
Yeah.
And so I was like, really, that's a good point. Why am I working on the things that is not critical for a business? Why am I not working on the thing for a business that believes in the same things that I believe in? And no, it wasn't just Kafka, it was believing in stream processing as a new paradigm that has a future, that is a thing that people want to do, that has the ability to change the world. And I'm like, I believe in the world changing, and I need to be in a place that is with the same thoughts and beliefs. So at that point, I started talking to Jay and Neha a lot more seriously. Like, I need to be here.
Yeah.
I like contributing to Kafka, but I need to be in a place that sees the future of it. So I was happy that they saw the same thing, the things I saw the same way.
Yeah.
And from the beginning, they were so supportive of the way that I wanted to shape my career. Because from day one, I was very clear. I'm going to work with you and I'm going to do my darnest to make this space successful. But after that, I want to start my own company because that was my dream for many years now, and I haven't been doing it, and I'm not getting any younger. And in order to be able to start my own company, I need to see different sides of the business. And Jay and Neha gave me this opportunity. I worked in engineering. I went to product. I went to marketing. I did DevRel. I did field marketing. I did professional services. I just went through all
You get to
those
see
things.
all the aspects of the business.
Yes, and it was such an amazing, 7-year school of how to build all aspects of the business, from 20 engineer company to, I don't even know, like 2,000 plus people, like through the IPO. So it was just such a great time. Anyone who has an opportunity to work on a growing company that aligns with their beliefs, highly, highly recommended. Best
Well, that's cool.
experience of my life, probably.
You mean better than going to business school and getting an MBA?
Oh, for sure, because you get to learn from people at the top of the business. While in marketing, I had opportunity to report directly to the CMO. And she was the CMO who took other companies public. She knew so much and she knew product marketing. And then, I worked closely with salespeople. Every time I'm with a star account executive in the field, they're giving me tips left and right. When, shut up before you say something the customer is not going to like. Say the minimum you need in order to make a sale. Things like listen more than you talk. It's just this. Every time I spend time with someone in a different field, I just learn so much. I had the opportunity to have Crix as my manager when I did product.
Yeah.
I have all those quotes that I can give you about how to do product. My manager in engineering was previously the guy who ran Aurora at AWS.
Okay.
Kamal, just one of the top engineering managers I had the pleasure of working with. And he had all those Amazon quotes. Is it a one-way door or a two-way door? Like all those things that kind of become part of the way you think after a while. And I think it's a good part of the way I think now.
So you had in your mind this whole time that you wanted to eventually create your own startup, and by being able to experience all the different parts of the business, that would better equip you to be able to lead and then ultimately scale a startup. Is that how you were looking at it at the time?
That was the idea, yeah. I'm not 100% sure it's working the way I imagined it, but every journey is just different. Some of the stuff I learned is useful, but it turns out that there is a lot of learnings that I did not learn back then that I'm learning now, which is good. This keeps life interesting.
Yeah. And it seems from the outside that you kept writing code the whole time. So I'm imagining that while you were even in marketing, it seemed like you've never stopped writing code and fixing Kafka when you were at Confluent. And
it's true to an extent. I'm looking now at if you look at my GitHub contributions, you can probably tell exactly when I was in engineering and when I wasn't.
Yeah.
So I had those maybe 100 contributions a year. That was probably when I did product, because engineers hate it when product try writing code, and they try to be respectful of people's sensibilities. So it has less code in that span of time. And now that I'm in my own startup and we're only 8 people and there's just so much to do, it's shaping up to be an 800 contributions year kind of thing. So you have ebbs and flows. I think Charity Major said it really well. She talked about the engineering manager pendulum, that life has waves to it. You have periods and seasons, and you do different things and focus on different things at different times.
So let's go on to your new startup and tell us about what you're doing and the journey over the last couple of years there.
Yeah, so I'll start at the very beginning. I think at the night before Confluent IPO, I was in New York. So I'm painting a picture. I am in New York for the big bell ringing in the NASDAQ. It's just at the tail end of the pandemic, maybe a few months after everyone got vaccinated. People are coming back into the wild. And I was sitting with two close colleagues, people I've been working with since day one, almost at Confluent for the last 7 years. And we were talking about, what do we do now? Like, we reached this point of success. What's next? Are you retiring, taking a big vacation? Like, what's going to happen now?
You've reached the top of the mountain. Now you're looking out and saying, where do I go next?
Yeah, exactly. And I was like, I want to start my own company. And Ram sitting across from me is like, yeah, I'm thinking the exact same thing. And I have this idea. And I was like, this is a fantastic idea. Maybe we should do it together. And so at the time, I was leading the Cloud Native Kafka organization, which was pretty big team at the time. I think we were like 20 people. So I was kind of getting my first footsteps into mentoring other managers. Ram, on the other hand, he built the 300-person cloud everything organization, basically built Confluent Cloud from scratch. So, and really a person I'm still looking up to very much. So it's like this opportunity to do something I'm deeply passionate about with someone I admire so much. I'm like, yes, this is it. This is what we're doing. And I think we announced that we were leaving maybe 3-4 months later. While we were doing customer calls, nights, evenings, weekends, whiteboarding ideas, all that. And yeah, we just.
Do you want to talk about the initial idea the for the company and what it was, or is that not relevant?
It is kind of relevant because it's a journey. So when we left Confluent, the main thing was, why did Ram need a 300-person organization to make Kafka a cloud service when Kafka itself was a significantly smaller organization? Why does it take more engineers to build a managed service than it is to build a database, essentially? It made absolutely no sense to us. So we started the journey into what would make it easier and what are the hard parts and what are the ways to build a better developer experience so you can do it with fewer developers, much faster, and also make it much more reliable, not reduce the ops burden. And we tried a bunch of ideas, and some of them died before we wrote a single line of code. But one of them actually seemed promising, which is to build it as a control plane. We took ideas from Kubernetes. We'll have those reconciliation loops. People will write those configurations as code of how they want authentication, how they want billing. And it will be like just a layer that you put on top of your system, like maybe a proxy or something like this. And when we started experimenting with it, we released our first version. And it turned out that nobody gets control planes. And the few people who get control plane want to build them themselves. So like just explaining to people what we do. So do you guys do Kubernetes? Well, not quite. So do you guys build a database? Well, not exactly. Are you guys authentication? Well, no, not really. So
I keep hearing stories like this. And I coached, sort of coached a startup weekend once, and they really emphasized making some kind of prototype really early. Because I've heard of people going through the whole process and building something and then discovering that, well, no, the customers don't actually want this. And you go, oh, yeah, that's something you really want to find out right away.
Yeah. So it sounds like that's what you did, was you built this control plane and then you started talking to customers about it pretty quickly. And then you got that feedback loop. You had a much tighter feedback loop where you're like, oh, we learned some things right away by building this and putting it in front of customers.
And it's like we are solving a pain point for them, but not in a way that they understand and can connect to. So this was new. I always thought that if I solve a pain point, it will be obvious. It was not obvious. So we went back to the drawing board, and for whatever reason, it was really obvious for us that the place to put all this value is not above the product, but under the product. That we actually, if we could do everything in the data layer, it would be a much better experience than trying to layer things on top of somebody else's product and interface with their APIs, because databases they're all the same. Essentially, they have SQL. They are actually a lot more standardized and understandable than API layers, where the variance and the integrations were just much more of a Wild West. And once we started saying, how can we add immense value to SaaS companies at the database layer And I still remember the day we were sitting in the Hacker Dojo in Mountain View, and it was just after a board meeting. We were like, we need a value that will be so clear, that's something that people really struggle with. And we're like, the hardest thing about a database when you're SaaS is your customers. You never know what they're going to do. You never know who is going to cause load. You never know who is going to fuck things up and you'll need to do a restore. And those things are so hard because most of the time you put all your customers in one database. And then when you need to do something for one of them or one of them is loaded, you're stuck. Or one of them has to be in London. Now you need to start an entirely new data center over in London because they have different rules and regulations. Like, this thing is the hardest, and databases don't even know your customers exist. They're thinking they're running one workload unless you actually go to the effort of giving each customer their own database, which is something nobody ever did at scale.
Yeah.
And wait, nobody ever did at scale. Is that just because of performance overhead?
There is a bunch to it, right? First of all, operational overhead. Like, you have to upgrade 3 databases. Usually, and still to this day, if you have to do a database upgrade, it's months worth of effort. And I actually did something similar to what you guys do. I invited a bunch of people who ran databases at scale for the biggest SaaS companies. I talked to Airtable, I talked to people from Figma. They didn't agree to be on the record, but so we had some private conversations too.
Yeah.
People are very generous with their time. But I try to share what I learned with the world as I was learning it. And then you really learn that database upgrades are really difficult and take a long time. Customers with different spikes in activity, it's
different traffic patterns create a lot of complexity.
Exactly.
Yeah.
Exactly. So we are like, we think this is the right place to add value.
So you had that like light bulb moment, which now looking back seems obvious, but it was like, how do we create a not the control plane, essentially the abstract control plane that allows you to do anything. You said, let's focus on the SaaS companies who need a database per customer, and how do we make that easy for them? Is that the right?
Exactly that. Yes. How do we make it easy for them? How do we allow them? A lot of times you have a database per customer. You need to do reporting. You need to do routing. You need all those operational tools. How do I back up, restore, all those things?
And upgrade, which you mentioned as being one of the...
How do we drive costs down?
Yeah.
All those things. So
billing, how do you decide the correlation between what the customer is using and what they should get billed? And with databases, is it about compute? Is it about storage? Is it about both? And
so if I understand correctly, the original databases were considered so heavyweight that they were designed that you're going to have a monolithic database, whereas what you're doing is saying, oh, we need to redesign this so that we can easily spin up a database per customer and deal with all the things. And the original ones just didn't support that kind of thing because the vision was wrong.
You know how containers basically change the game in the way that you can now run a lot of copies of the application and have easy ways of managing them.
Yep.
And we're like, the same way that containers change the application virtualization space, we can do the same for databases. We can give each tenant a virtual database. The developers will have the same operational developer experience of running one giant database and paying for shared resources, while we will actually be able to give this isolation inside the database. So this is what we call it. Nile provides virtual tenant databases, and this is what we're currently all in on building, because remember the old rule, never build a database? We're obviously breaking it a bit. We are building on top of Postgres, but we are making big architectural changes inside Postgres. And we are, on one hand, it's really hard. So for us, our engineering is obviously stretched. On the other hand, we're benefiting from it because, in a way, this is our mode.
Yeah.
Unlike control planes, which turns out that everyone wants to build, we can actually talk to people about the value we bring in a database, and the people get it.
No one wants to build a database virtualization layer.
So it's actually, it feels right at this point in time.
Oh, yeah.
Let's talk for a minute about virtualization. So Bruce and I were talking this morning about some of these like fundamental constructs of programming, and one that we didn't talk about was virtualization. So virtualization is being able to abstract over physical resources. How would you put it? How would you say what just the concept of virtualization is?
Yeah, I definitely think it's a layer of abstraction. And I think it's not necessarily just over physical resources. I think it can be, because if you think about the way Docker works, it doesn't just virtualize physical resources, it virtualizes the operating system itself, right? It uses things like C groups, and it uses things like jails and chroot and all those things to basically create what looks like an operating system, except it really isn't. And this is very different from, let's say, the firecracker approach, right? That is an actual mini virtual machine, and they managed to make this mini virtual machine extremely lightweight in a way that was not possible before. So it's a different layer of virtualization. And I think I would call both of them virtualization, even though one of them is obviously a lot lower level than the other one.
Different approaches. And then I guess one important aspect in the SaaS use of virtualization, and maybe many uses of virtualization, is the like sandboxing, being able to make sure that customers can't see into other customers' workloads, can't do anything malicious against those, and then being able to control resource utilization. So being able to say, like, this customer can't saturate a whole entire machine. You need to be able to split the prioritization of running things across customers and all that. So
you nailed it. Absolutely. We call it tenant isolation. And you're 100% right that there is two sides to tenant isolation. There is the security isolation, and there is the performance isolation. And you really need to solve both of them. One of them is obviously a lot more critical than the other. Customers will tolerate small performance issues way more than they will tolerate small security issues.
Yes. Yeah.
I don't know if there is a thing as a small data leak, to be honest. So we are.
So that security, being able to ensure security is priority number one in the world of virtualization.
Yeah, you want a air gap, basically. You want some software equivalent of an air gap.
Yeah. It's like, do not even allow it.
It's just, we can't even see them.
Yeah.
And you really need to nail the developer experience, because in an ideal world, the developer will not even be able to look at the customer data. In a practical world, developers need to debug their application. So you need to be very clear about when developers get those super user permissions and maybe even get consent for that. So you really need to get a good experience for developers when they're debugging an app versus a good production experience where you cannot make those mistakes. This is a very common pattern. If you think about it, you are building a small application. I always use to-do list as an example. So let's say that. And users connect to your application. They authenticate with your application, or maybe they get a token from another service, but then they authenticate to your application. But then your application uses a single connection pool to the database. Every single connection to the database has the same user with permission to see everyone's data.
Right. Yeah.
This is the scariest thing in the world for me.
Terrifying.
And with a developer getting the exact word clauses correct in every single place in their code, this is terrifying. So this is, one of the first things we're tackling is how do we build into current developer tools the ability to pick the user and the tenant at the authentication point, push it down to the database, and from that point on, the connection is no longer talking to a general database with everyone's data. It is talking to the virtual database for this specific tenant that you just authenticated as. You will never see anyone else's data on that connection because the authentication is
I
going
also have
down to
another
the
idea here. This just popped into my head as you were saying it. When you do that, I could imagine another operation, which would be to take all the user data and just kind of obfuscate it, so it would still be the same form, but it wouldn't be the actual data. So that even if a developer screwed up and, I don't know, opened the door to the internet, the data that they would get would be the right form, but it wouldn't be anything usable.
Yeah, could you create another virtualization layer that was like an obfuscated version of the database, as an example?
This is actually something that we're kind of exploring now, not so much as in what you said, like open to the world but obfuscated, but more in the idea that database branches are becoming popular these days. And people want to take the production database and create a developer branch where they will get to work in developer environment. Can be super important if you want to test your code with real world production data, right? It makes a lot of sense. But is a branch
data security gets really hard.
An obfuscated branch is a very good point. So this is something we're playing with. I think it's one of the magic of branches is obviously that it is copy on write. So if you just do some kind of performance benchmark that is really heavy, it doesn't actually cost all that much. Obfuscation is interesting because it means you don't want to obfuscate the actual data, right? But you may want to obfuscate it in memory, for example. So you wouldn't create a modification. So this is definitely a bunch of ideas that we're kind of goofing around with right now. It will probably be a while until it gets to production, but like not something that I'm willing to give dates on. But it's exactly, this is the thing that excites us so much. The moment you hit on the idea of virtual databases, the possibilities it opens are so wide. So I can see myself staying excited and kind of delivering this kind of value for many, many years to come.
Well, it seems like there's so much you can do once you have this lightweight virtualization layer over databases, because sure, you could do a fork that has obfuscated data, or you could do a fork that has particular ACLs applied to it so that you can only read from particular columns or something like that. And so there's just all sorts of different things you can do when you start to think about a database as being virtualizable across customers, across different users or uses within it, across. I'm sure like data analytics would be a huge use for this. Is like being able to have your data warehouse be based on some virtualization of the actual data or something.
But another thing that we were talking about this morning was the fundamental model of a database, which it seems like you establish the types at the front, and yet when you're doing a search or whatever, you're actually creating a new type, but because the types have been established in the front, you have to work around that. And so we were talking about, I think, more of a functional model for a database, similar to what Quill does in
the Scala Quill library.
The Scala Quill library, which I don't know if you've looked at it all. But it's a different way of thinking about I'm looking at this and thinking in terms of types, and I think what got us started was your interest in object relational mappings, and I thought it was Martin Fowler sometime in the last 10 years where he looked at that and he goes, okay, this has a limit to it. You could, as long as everything is simple. And James came up with a maxim which I captured, which is it works until it doesn't. And yeah, right. Doesn't you go, oh yeah, that covers a lot in programming. But the idea that, oh yeah, sure, as long as you're doing some, simple Ruby on Rails like thing where you're just going, okay, here's the data and it maps perfectly, great. But that only gets you so far. As soon as you start to have to modify things, then the object relational mapping thing kind of breaks down. And I'm curious about what your perspective is on all that.
Yeah, it's funny because I come very much from the database world, where for a long time data architects thought that ORMs are evil because they would look at the data model and says, okay, you need to do things in that way, normalize here, denormalize there, have those tables, and then engineers would go, A, my ORM doesn't even support what you're currently doing.
Right.
And B, even if it does this stupid in-memory join. It does not use the database effectively.
Yep.
And then you have to start finding workarounds for the ORM. And so you kind of get the pain from both sides. Engineers don't get the data model that they want, and the data architects don't get the data model they want, and everyone sees the ORM as the villain in the story.
It sure is nice for developer productivity, but the downsides that you get by having the developer productivity are, at some point not
It
worth
seems
it.
like it hits the wall pretty fast in
I don't
some
know
cases.
that it's just productivity though, right? Because type safety on the application side is not just about productivity. It is about code correctness at the end of the day. It's
Reliability.
about getting the most out of the programming language of your choice. So this is the problem, right? There's really good reasons not to trade off your
Yeah.
type system for like your programming language type system for what the database gives you. And there are also good reasons not to trade off what the database gives you into the
This is like the age-old impedance mismatch between how the data should be stored and how the application developer wants to work with the data.
Yeah, so obviously, like really strong team just build a very strong DAO layer where they build those microservices with a data layer for each one that perfectly maps the API layer into a type model and the type model into the data model, and it's all very handwritten, which is, I guess, where the hit on developer productivity shows up.
Yeah.
But I also want to say that not all ORMs are made equal.
Mhm.
And there are ones that give you, first of all, learning your ORM and when it makes sense to use it and when you need to overwrite it is extremely valuable. You can go a long way being productive with Rails and then tell Rails, okay, over here, you're absolutely wrong.
Yeah.
And then
Like
there are ORMs.
like a lot of ORMs do have the escape hatch that says like, I'm gonna, generate what I think is the right SQL query, but if you want to go override that query, you can. So yeah, they
Exactly.
often
And
do have these escape hatches.
the extent at which ORMs are willing to work with my data model versus what they want to do differs a lot. Some of them are so opinionated that if you as a developer or data architect have any opinions of your own, you will not be able to work with them.
Yeah.
And others are like, I mean, our job is to translate what you did in the database into objects. We may need more hints, but we're not going to tell you how to build your data model. We're just going to help you with the translation.
Yeah.
And yeah, I mean, definitely, if you have a choice of ORMs in your language, err on the side that that works with you and does not try to impose their opinions on what you're going to do.
Yeah. Well, and it maybe depends on how is there a database person on your team or many people, and do they care about the data model? Are they doing optimizations in the data model? Are they doing things, views, but in a lot of cases, I'm sure that developers, they're the ones in charge of the database, and so they're not doing all the optimizations, and they don't care about how the data is stored and structured and queried and all that. And so you reach a point where it's like, okay, the developer is no longer in charge of the data, and then does the model for interacting with the data that they were using work? And I think in a lot of cases with ORMs, it's like, no, like you're probably not going to be able to take the model that worked when you didn't have a data person to now having a data person.
Because if you look at Ruby on Rails, for its target is like, well, we want to be able to put up a website really fast and not have to spend any time coming up with the data
architecture,
architecture, or whatever. It's just like, okay, so it's this nice, straightforward, linear thing, and only if you put up a successful website and it starts to scale, and then you start having to think about, oh, wow, we're having
this got slow.
Yeah, this got mostly it's performance issues, I would suspect.
Yeah.
So I have to plug someone that I met fairly recently. He wrote the high performance Rails and Postgres book. And apparently this guy's entire career, and we're going back, I don't know, like 20 years, is basically to show up at companies at the exact point where we threw some Ruby and Rails on top of a database and now it no longer scales, and figure it out how to grow this into something that actually works. And he did it at like 3-4 different companies at different stages of growth. And now he wrote a book, and now he does this as a consultant. And this is such a great niche for a human to be in, because you're exactly right. You have a team of hackers, they want to move fast, they throw in some Rails on top of a database, and now what? Now what do we do? We were accidentally successful, but now what do we do with this data model that no longer works for us? And we never spent a single hour of our life thinking about it. So
I guess part of what you've been thinking about is, could we get to a model based on database virtualization that would allow us to start with the thing that will scale later, like, but have the nice, concise, good developer experience at the beginning, but not be then constrained later? And maybe with the foundation of database virtualization, we can actually like start with the easy thing and have it scale with us as our data architecture and performance needs are changing and growing.
Too much overhead on the, because anytime
side,
you do that, you're always going to impose some overhead at the simple, quote unquote, simple end.
Yeah, so this is exactly what we're exploring. Like, this is our mission. And something about me and my co-founder, we're very optimistic. Just because people have not been able to build a good ORM so far does not mean it's possible. It's impossible. Just because there is this big step in between what works when it's easy and fast and what you need later doesn't mean that we cannot kind of smooth it into a nicer curve. So I cannot be here and just say, oh, we solved it. But this is exactly the kind of thing we are trying to solve. Can we smooth the learning curve? Can we smooth the adoption curve? Can we start you off in a place that has a tiny step and then add more steps as you grow, instead of starting off at no steps and then having one gigantic step to climb over all at once?
So the one thing I see a challenge could arise is that you might need to so fundamentally change the idea of a database that it might be too hard for, well, so one of my original experiences was in C++, and I was on the standards committee for 8 years. And I know that one of the things that Strustrup was trying to do was say, okay, all these people know C, and we want to give them a path to learn a more sophisticated language. And that was great at the time, but then it has become an albatross around the neck of C++ programmers. And so if you change, I mean, what you do might be what we eventually get to, but if it's too soon, that, and there's no path.
How do you create
How
the
do you-
bridge from what people know
Exactly,
today,
'cause
which is
there's-
most people know CRUD and
Yes.
SQL
On the
and
other
Right.
hand, Scala did it really well, right? I mean, they started with we want to get Java developers into more sophisticated ways of writing code, and we're going to start by making better Java. Just
Yeah.
those small quality of life things that everyone knew Java should have for decades, those nicer features, this apply, traits, all those things that are really fun to start with. And yes, they are extra effort. I had to learn traits, but you get it fairly quickly and you see the benefits fairly quickly and can slowly move on to make more and more out of the language. And if you stop at better Java, it's fine.
Yeah.
You still have better Java. I mean, these
Yeah.
days you'd probably do it with Kotlin, but you see where I'm getting to.
Yeah, totally. Yeah, so like you have to start from something familiar and then figure out how you can then evolve beyond
But there was
that.
a lot of foundations laid for. I mean, there had to be forays into. Well, I mean, like Scala, which isn't. I mean, it's not going to take over the world. It's got too many experiments in it, but then we had, by pushing that far, then we could kind of back off to Kotlin, and we see, okay, all of these learnings have been incorporated into this language, and it is just so much better. And I think we'll see a more and more of a transition from Java to Kotlin and languages like it.
Yeah.
But it requires, I mean, we had to get a bunch of people, maybe some percentage of the programming community to the point where they go, yes, this makes sense. Whereas if you just took if you took Java programmers and, well, obviously throwing them into the Scala pool didn't, only a small fragment of the programmers were ready for that.
Yeah.
So, I don't know.
So I think from your days in Kafka, one of the things that I was kind of hopeful of is that if you look at CQRS, event sourcing, some of those architectural models, it seems like those models at a certain scale make a lot of sense. But the downside to them is that the overhead to get into that architecture was very high. To build a whole, like a real system that used, let's say, CQRS, like, oh my God, like if you compare that to the world of a CRUD database, the number of the amount of complexity and number of things that the developer needs to understand is way higher on the complexity scale. And so it's like, yeah, CQRS makes sense at this scale, CRUD makes sense at this scale. And so I think the question that you're exploring is, how do we create a model that doesn't have to pick a side, where you get like the nice simple models that then also work at scale, and how do you do that around a virtualized database?
Yeah, so this is not something that we are exactly tackling, but a bit roundabout way around it is that when you think about when and how you need CQRS, you start with you have a monolith and you have a database, right?
Yeah.
And then usually the first step that people do is create microservices that all talk to the same database.
Yeah.
Which is
Single.
obviously not going to end well.
Yep.
And then when you transition them to microservices, the transition is everyone is going to have their own database. And now you can no longer just reach out into
There's no
some
join.
data and grab it.
Yep.
Right?
You've lost your join, and so then what do you do? And
exactly.
so then
And
with, you're saying, is CQRS with some materialized views is then a model that can give you the join, the benefits of a join in a database, but with the distributed data model.
yeah, and we're even thinking like some of the time when people move into this QoS model and you're not allowed to talk to my database, you have to talk to me and I will give you the data that you need out of my database. You have real APIs. Sometimes the APIs have real business logic and are very thoughtful, but sometimes they're a very thin layer on top of, as you said, some views, essentially. Like it doesn't do all that much. And this is something that we believe databases should provide a REST layer. That if all the values that your application provides, that your service provides, is some REST APIs on top of some views, you don't need an entire service. You don't need to manage its uptime. You don't need to deploy it. All you need is a REST API on top of a view. So this is something that I think, again, can dramatically improve developer productivity without introducing, I hope, we're just starting to explore it, but without introducing massive pains down the line.
Well, and once you're in the world of virtualized databases, maybe there's an opportunity to have a hierarchy of virtualization. And so your then materialized view could actually be a virtualization on top of other virtualizations. And so then, I mean, maybe performance wise, it all doesn't work, but it's, once you've got the concept of virtualization of a database, couldn't you then layer those virtualizations so that you could essentially create the same construct as a materialized view across different disparate actual databases or something?
That's a pretty good idea. And there goes my weekend. It is a good idea.
But because like maybe where you started is just creating one layer of virtualization, but why not have as many layers of virtualization as you want?
And views can be materialized. And obviously materialized views is a good abstraction of a stream of events.
Yeah.
So I think you're onto something here.
Nice.
James has lots of good ideas.
Well, the part of what led me to thinking about this was that a view in a database is not distributable, right? Like like as far as I know with databases, you can't create a view that actually like crosses multiple actual databases, right? But what we want in the distributed systems world is the materialized view, which does materialize across different data sources. So now that you've got a virtualization layer,
so
like your view is just a virtualized database, right?
So we do have virtual, like distributed views that
cool.
we route the requests and then we kind of collect the result for you.
That's cool.
But you're right that it has a performance overhead. And if we did it for materialized views, we could do it better.
Yeah, nice. So touching back on the ORM subject, is one of the challenges that we have with ORMs, like kind of this relates back to views, is that views are not well represented by ORMs because you may have different ways that you want to aggregate data or view data. And in the world of objects and types, it typically is very cumbersome to establish different types for different views. Is that one of the challenges that we experience in that, like, the way that we want to view the data changes? And so what do we do? Just write SQL queries because SQL queries allow us to pick the columns that we want to get.
So I hope that as databases evolve, and you can see it not just in Nile, databases are evolving all the time, and there is materialized which have view-centric database, and there are also new ORMs being written all the time. So one would hope that newer ORMs would be adapting to changes in the world. And we're definitely seeing it happen. I think TypeScript ecosystem, which traditionally has been a lot faster moving and very dynamic, you see it maybe a bit more than in other places. But it's definitely a thing.
Well, and maybe there's an opportunity for languages that have algebraic data types, product types, and some types to use ADTs to better represent the views that you would want on your data or something like that. So there may be, and I'm pretty sure TypeScript has ADTs, so maybe that's one place where there is some possible experimenting. Maybe it already exists.
Ultimately, what you want when you go to your database is a type, is a collection of things of a particular type. You don't want to have to go through all of that intermediate stuff, which is just an artifact of how databases got started.
Yeah.
Exactly that. And you also think, like, again, if you're thinking about microservices, you're talking to a database and you get types maybe via your ORM. You're talking to other services. You also need shared types for the replies that the other service
Uh-huh.
gives you, right? So you have those open APIs and gRPC and all those things that are very typeful, and you have to manage it this way. But why does it have to be different? Why do I
Yeah.
get my types one way when I'm talking to my database and my types in a totally different way when I'm talking to the other service? When at the end of the day, all I want is some instances of some objects
Yeah.
with the data that I'm looking for.
And this is my original observation, is that the reason it's different is because with a database, you set your types at the front end and not at the end where the user, the person getting the query gets them. And I'd say that's where the disconnect is.
We still haven't really figured out where schemas should be defined, how they should evolve. I think Google generally uses protos to define their data schemas, and protos, because they're evolvable, I think that does give you a way to at least define schema and evolve it, and then generate the application layer types from those. I'm sure there's some trade-offs and downsides to doing the schema definition that way, but yeah, schemas becomes one of the other challenging things that I'm sure you're thinking about is when and how do schemas get defined? How do they get modified? How do you deal with splitting a column into two columns? Like, there's all sorts of challenging data migration problems. So I'm sure that's something that you're also
Data
trying to tackle at the
migration,
same time.
exactly. Data migrations is extremely hard and extremely painful, and something that tools already exist and they're very opinionated. And how to work with existing tools ecosystem while applying migrations in a way that actually work in a distributed database. Because if you
Right.
think about it, it's multi-tenant. You have the tenant virtual databases. Migrations traditionally think about schema as one thing. They don't
Yeah.
think, oh, this tenant is on the new schema, this tenant is on the old schema. But you as a developer, when you upgrade, it's actually really beneficial to say, okay, this tenant is actually my product manager. It's a canary. I'm
Yeah.
going to upgrade them first to the new schema. If anything breaks, it's going to be on them.
Canary migrations. Oh my God,
Yes,
that's
let's bring
amazing.
databases to the 21st century.
Yeah.
Exactly
Yeah.
that.
Huh.
Oh, there's your tagline for your company.
There you go.
Which will work for 100 years.
Yeah, that's right. Bringing databases to the 21st century.
Yeah,
I like
that's
it.
not a bad idea.
Yeah. Some cool stuff, some really challenging problems that you're trying to tackle, like making
We're
this
hiring,
all.
by the way. If anyone is listening and wants to tackle a challenging problem.
That's right. There's some really fun problems you could go work on at Nile. So that's yep, that sounds fun. What other topics that we haven't touched on that are interesting to you at the moment?
I'm out of topics. What about
Out of
you?
topics. Okay.
I guess that's a good sign. We've exhausted the queue.
It always happens around the hour.
It does. Something
Which
about
is,
our
how is
brains
it?
just
How does that work? I don't know.
reach the
It's very mysterious.
yeah. Well, cool. Well, Gwen, it's been super interesting to talk to you, and I haven't tried Nile. I don't know if I'm the target user for it because I'm not building a SaaS platform, but I think you're doing so much in terms of exploring not just the SaaS side of databases, but also the developer experience side for how developers interact with data and deal with security and deal with migrations and deal with all these other problems that probably be interesting for me just to see how you're thinking about some of these problems. So I need to go play with Nile and
I have to say that this was
see what you've done.
fascinating. I think I got some different perspective. I've always avoided databases, but the ideas of them are interesting, and I think I've gotten some different perspectives on it.
Yeah, so maybe Nile can someday reach a point where Bruce will be interested in it because it will have
it doesn't
changed the model.
It isn't an immediate drop into the weird details of SQL and joins and stuff.
Yeah.
It's like that's always felt to me like it's like, oh, I mean, I used to program in assembly language, but I don't want to do that anymore. And this feels like throwing you back into that.
SQL is the assembly language of the database.
Kind of is.
No, it was meant to be English-like and clear to everyone. That's why we're stuck with things like select and where. And
So was COBOL.
Yeah.
Yeah.
I not a fan of SQL personally, but
Yeah.
but some people love it.
Yeah.
Well, thank you so much, Gwen.
Yeah.
It's been awesome to have you. Appreciate it.
it's been a pleasure to be on one of my favorite podcasts.
Oh,
Nice.
thanks.
Thank you. Bye.